Morning, everybody. Okay, so there was a kind of a flurry of announcements that came out this morning. All right. First was the fact that somebody had been asking me for Discord links, and I got it from the person that runs it, and I put that up. So if you're not on the Discord, you can go to that link and get on. And then I just finally decided that I really wasn't going to change the homework due dates at all, with the sole exception of moving the Wednesday due dates to Tuesdays before exams. That does not affect the current assignment. So chapter, what are we on, 20, is still due tomorrow, okay? But moving forward, and this, as several of you pointed out, aligns us with what I did in 2A last semester anyway. So it's a return to form, and I thought that was probably the best way to go about doing it. But so thank you. It's a lot of work for doing something that I should have done in the first place. All right, so those are the kind of items of business. We've got the exam one topics. Before we get into like physics questions, what are your questions about the exam process? I know many of you have had many, and so you're basically familiar, but what do you need reminders of? What are you worried about? Nothing? We're good? Okay, so for the 3 or 4 people that haven't had me before, what kind of advice would you give to somebody who was going to go into a Mr. Balogh exam for the first time?
Start with the non-math questions.
Start with the non-math questions. That works for you. So there's usually 1, maybe 2 questions that are like kind of purely conceptual in nature. So why do you do that? Is it because you can do them fast, or because it takes you a while?
It gets me in the right mindset for the exam, actually.
Kind of warms up your brain.
Yeah, instead of jumping right into numbers and being like, ugh.
Right?
Yeah.
Okay. And how do you know which one is the conceptual question? It's multiple choice. It's the only question on the exam that will have choices for the answer. So that's good advice. Any other advice you give to somebody? Somebody hasn't taken my test before, right? What would you tell them?
I was gonna say, actually, with multiple choice, it is sometimes a lot easier to mark things wrong than it is to first identify what's right.
Yeah, and this is something I always tell students too, right? Tell me why that's wrong. Because sometimes you come up to me and say, I can't explain why this is right. And I'm like, do you know why this one's wrong? Well, yeah, tell me why that one's wrong, right? You can eliminate things. Was it Komal? Did you say something? No?
I was just gonna say, don't dwell on one question for really long. Just write what you know.
Really pace yourself. Write what you know. Don't worry if you can't answer it right away. Come back to it.
I'm gonna say something very similar. Just start off. I know it's a lot, but start off with the easy questions. Is really the way.
Start off with the easy questions and like what's easy for you. Because what's easy for you might not be for somebody else, right? But certainly don't do the test in order. I mean, you can go through it in order, but if you're getting stuck on that one, move to another one, right? Flip through the test and see if you can't figure out which one is which, right? You know ahead of time. So there's 7 things up here. There's going to be a question about electrical power. How do you tell if the question's about electrical power? What's a dead giveaway that it's going to involve electrical power? Watts. Kilowatt hours, right? Right? So it's we talk, so you have context for this, right? How do you know if it's electric potential versus electric field? I mean, both are going to involve charges, aren't they? Both are going to probably involve distances. But you want to key in on words of what's the electric potential at so-and-so? What's the electric field at so-and-so? And between those two, in general, which one's harder? Field or potential? Potential's harder? Yes, no, it just depends on you. For me, electric field's harder because it's just got a bunch of vectors in it and I don't like vectors. Right? I'll go for potential all day long because I really just have to calculate a number and add things together, right? So, but other people are more comfortable with the vector stuff, right? So be able to, spend just a few minutes at the beginning identifying what these questions are. Go, oh, okay, yeah, I remember, right? I can do this one. Other advice that you give to somebody that's never taken a test?
A light but well-written reference sheet for the exam is better and usually more helpful than like packing everything in that we learned.
Yeah, if you pack in everything you learn, you're not gonna be able to find stuff, right? Okay, so yeah, I mean, that's good advice, right? Definite things that you should have on your cheat sheets are what? All the equations that you think you might want to remember. I know some of them get burned into your brain, but others, you step into that exam and your brain goes blank. Can't remember what the potential is, can't remember what the electric field is. Having that on a piece of paper to jog your memory, very, very helpful. Yeah.
Always make an attempt on the question, don't just leave something
Don't just leave it blank, right? If you leave it blank, it's just -2, right, and move on, right? Try to show me what you know. There's a chance I might give you 1 point out of the 2 on the question. Any other pieces of advice? Yeah.
This is not so much about the test itself, but like studying and making your cheat sheet, but look at the learning study guide in the learning resource.
Ah, yes, okay. So, thank you, Hannah, for reminding me about this. Because even I forget about it. But if you go to chapter 20, okay, the learning resources, right? Which is the part everybody ignores because it's the book, right?
Yeah.
You can go straight to the sections, okay, fine. You got the pre-lecture videos. I'm not going to ask who uses these because I can go find that information. My 2A students this semester are using these. It's weird. It's not a question of better or not. It's just, it's weird. Like, I showed them this and then they just started using it. Unlike you guys that didn't. Anyway, but yeah, down here at the bottom, okay, there is a student study guide and then the solutions manual, right? If you go in the student study guide, takes you, surprisingly, to the study guide where they give you the glossary of terms. They give you equations. Now, did we do the temperature coefficient of resistivity?
No.
No. Do we need to put this on your cheat sheet? No. Right? Okay. Did we do electric power? We sure did. We didn't do anything with alternating currents, right? But the series rules are here, okay? All that kind of stuff, right? Okay. So it does. It's got a lot of stuff in it, right? Okay. And in my mind, it's a great thing to have for after you've come to grips with the material in some way, shape, or form, right? You don't start with the student study guide, right? Okay. And you can if you want, but there won't be a lot of context there. We didn't do Kirchhoff's loop rules, but we did do series and parallel. And down at the bottom, there's more practice problems. Because what everybody wants is more practice problems, right? But yeah, you need them. So yes, thank you, Hannah. Good resource. All right, what are your questions about the material, about physics, about life? I'm at your disposal. Yes, sir.
Could you go over the concepts for electric field and electric power?
Concepts? I mean, the electric field is the pattern of forces that exists around all charges. Okay? That's basically kind of what it is in concept, right? In practice, the way that we go about working with it is we draw pictures. Right? So if that's a positive charge and I want to know the electric field right there, conceptually I know that electric fields start on positive charges and move like outwards and away from them, right? So if that's the point I'm talking about, my electric field vector would look like that at that point, right? What would it look like if I got closer? Well, it would be a bigger vector because the electric field is stronger. And this is a picture that's driven by this, right? The closer you get to a charge, the bigger the electric field is going to be. The bigger the charge, the bigger electric. The further away you get from it, the smaller it's going to be. We do conceptualize these fields using these lines of electric field, okay? And those lines give me a pattern so that I can, hello bug. In my wife's family, those are called beezers.
It was a bug. It landed on the projector.
Yeah,
Oh, there it is.
it's like a, is it a moth?
Uh-huh.
Looks like it. It wants to learn physics. It does. It'll do that. It may or may not make its way out. We'll see.
There you go. You do it. Oh, you're so close.
Struggle bus.
Yeah, we're gonna be distracted for a while. Try to ignore the moth. All right, so how did I know the electric field is pointing down this way? What is this pattern of field lines trying to suggest to my mind? It's moving outwards, right? But the lines aren't real, they don't exist. They're an abstraction. That helps me see, okay, I can tell what the field is doing. And so that if I come to this point, well, it's gotta be going something like that. If I'm over here, it's just gonna be following along like that, right? So conceptually, there's a strong conceptual power to what the field is telling us. But in the end, it all comes down to Coulomb's law, because that field, did it make it out?
Yes.
Okay. That field tells me that a charge would experience a force. If I put a charge at that point in the field, it's going to experience a force that's directed in the same direction as the field. Unless it's a negative charge, in which case everything is opposite, right? Okay. So, yeah, it's fun. So, I don't know if that quite gets to your question there, Jordan, right? About like the concept of the field. The concept of power, I mean, there really just isn't so much a concept as it is a calculation. It's work per time. It's energy per time. How much energy is flowing? We always did it in the context of wires, right? How much energy is flowing through a light bulb, right? We can take the electrical energy, divide by the time. There we go. Did that answer your question a little bit? Okay. We did talk about the concepts of like kilowatt hour, but that's a unit of energy. That's what we're charged for by PG&E, that kind of stuff. Yeah.
In terms of equations, when there is a capital Q versus a lowercase, is there typically a real big difference, or is it just charge?
It's just charge. Your book uses little q's everywhere. I use capital Q to talk about the thing that's causing the field, and little q to talk about the thing that's experiencing it. That's usually that's actually a very standard symbology amongst physicists. I should probably stop using it in class. But yeah, capital Q being caused by. It's a little bit like when we did Newton's universal law of gravitation, and there was the big M was for like the mass of the planet, and then little m was the mass of the satellite. Big Q is the thing that's causing the field. Little q is the thing that's in the field experience. It's kind of sloppy on mine. Let's go over here to.
I'll hold my question.
Okay, Christian.
Can I do number 10 on chapter 18?
18?
Yeah.
Because I'm here and I'm remembering it, what can you always do once the thing is due? You go back and you can hit the solution button, right? Okay, and it will show you what was done, okay? So this should have been a straight up yeah, it's even showing us right there on the solutions manual. A straight up, Christian, I'm not trying to make you feel dumb. But I suspect that if you did it this way and got the wrong number, that there's just a calculator error.
My calculator's computer.
Okay, shoot me an email, I can give you credit. Do you need to know how to do this problem?
I don't know if I even submitted the answer on the
Okay.
website.
Okay, so in the problem, they use a lot of words to basically say we're gonna calculate the force between the bases in a DNA molecule, right? And the charge on each of the bases is the charge on the electron. That's what they give us, the fundamental charge. And I think, is this the problem that didn't do, yeah. Equal and opposite charge is a plus or minus lowercase e. They didn't do a real good job of putting in like lowercase e is the charge on the electron. It's actually a symbol that is used in physics to just denote the charge on the electron, okay? So knowing that we're just calculating Coulomb's law, is K, Q1, Q2, over R squared, I'll just use capitals, right? 8.99 times 10 to the 9th, and then the charge on the electron, 1.6 times 10 to the minus 19 coulombs. And then I do that again, so I'll just square mine. And then they gave me a distance, didn't they? 0.3 nanometers, how am I gonna put that distance in? 0.3 times 10 to the negative 9, good. Did memorizing nano and micro and milli help? That's fine. Alright. That should be the answer. Whatever that number turns out to be. Yeah, it didn't work. Yeah, 8.99 charge squared. Why did they did 3 times 10 to the minus 10. 0.3 times 10 to the minus 9 is the same number. How do you enter this into Wiley plus 2.6 times 10 to the minus 9? Use that capital E, right? 0.6 E minus.
Mine actually do crazy.
Does it?
Yeah, I think it's hazy though.
Usually it's uppercase, but
Can we do number 3 from chapter 18?
19? It's gonna take me a while to get there because Wiley plus doesn't let me open multiple. Which 3 did you say?
3. No, wait. Yeah, this one.
This one?
Yeah.
It's 2 questions, right? We're gonna find the potential, the electric potential energy of a charge at point A. And then we're gonna do it again for B. Let's do it for A first. To find the electric potential energy of any charge, I need the charge times the voltage of where that thing is at. And I know that because voltage is defined as the electric potential energy divided by charge. All right, so the charge they gave me, the negative 6 times 10 to the minus 9, that's the little q that's going to be in there. But I've got to go and find the voltage. I got to find the potential at point A because of the other 2 charges. And we know that the potential of a point charge, kq over r. So I can find the potential at point A by finding the potential from charge 1 and adding it to the potential of charge 2. Let's do charge 2 first, the easier charge at point A. So charge 2 is going to be K, right? And then it's going to be Q2 all over the distance from charge 2 to point A. And what is that distance in this problem? It's 0.25 meters, right? So this is going to be the constant times the charge, 4 times 10 to the minus 9, all over 0.25. Not squared, which is the number I always want to square, and if I got it wrong, the first thing I check is, did I square my r's? Yeah. Okay, but to find the potential from charge number 1, the distance is not 0.25. The distance from charge 1 to point A is along the diagonal of the square. It's going to be root 2 times 0.25 because it's a square. So 0.25 times root 2 would be that distance. So again, it'll be the force constant 1.5 times 10 to the minus 9 all over the distance 0.25 times the square root of 2. Once I've got those numbers, I add them together, right? Both of these go into here, and then that voltage goes into there. This charge is the one that's placed, -6 times 10 to the minus 9 coulombs. And I believe that the negative sign matters. Yep. I don't want to put all the numbers in. Am I answering your question for you?
So the unit is joules.
Yep.
Okay.
Mm-hmm.
I just want to
It's potential energy.
correct.
Mm-hmm.
Got it.
Yeah,
And I'm feeling I scored ours.
it's very possible. Okay, so what do we do for B? Yeah.
Why did you put the root
The distance, right there. I need, so for the potential from charge number 1, I need this distance. And this is a 45-45 right triangle. It's the square root, so the long way is 0.25 squared plus 0.25 squared. Okay, but this is 2 times 0.25 squared, is it not? And what's 0.25 squared? Square rooted. 0.25, and what's left? Square root of 2. So the square root of 2 is a shortcut in trig for when you have a 45-45 right triangle. You probably learned, if you learned it all, root 2, 1, 1. Right? And then the other one was, oh golly, I can't remember now. 1, 3, square root of 3 over 2 or something like that? I don't remember that one. But anyway, there were all these relationships. This is the one that stuck for me. When you've got a square, the diagonal is just root 2 times the length of the side. It's a shortcut with not having to do the Pythagorean. Yeah, do the Pythagorean theorem, it's great. Still works. After all these years. Did that answer your question?
Yes.
Okay.
Thank you.
For the green one, just make sure, or for point B, your distances swap, right? Okay, so V2 is going to be over 0.25 times the square root of 2, and V1 is going to be over just 0.25. Because you got to mind the distance. Yeah.
Which of the, is it point charges that we use to decide?
When you're calculating potential, you need to use the sign. Potential is not a vector, and so the positive and negatives are meaningful in the actual calculation of that scalar quantity. With electric fields and forces, we calculate the magnitude of the force, and we use a vector drawing to figure out direction. The positive, negative comes from the drawing.
So it's magnitude, we don't use.
Yes. And with electric potential, even though it's just a scalar, it's just a magnitude thing, positive and negative mean something. It's very important. There's a way to calculate electric fields in Coulomb's law using positive and negative, but you have to be very careful with your vectors. So we teach you, believe it or not, the simplified form of potential, mind the signs, everything else, just calculate the number and use a drawing. How the vectors, which way is positive and negative vectors. Yeah.
Chapter 18.
Number 4 in chapter 18. You guys just want to see me bounce back and forth between web pages.
Sorry.
No, it's not your fault. It's Wiley Plus's fault. In that it doesn't let me open all of the assignments at the same time. You said number 4. Is that right? Don't you hate tiny conducting spheres? So for part A, calculating the force between the spheres. What are we using? Coulomb's law, it's a force, right? So the force is going to be KQ1, Q2 over R squared. And as long as we put the charges in with that substituting the micro symbol, what do we put in for micro? 10 to the minus 6. And what do we do with the 3.42 centimeters? Convert it to meters, right? And centi means 100, 10 to the minus 2, okay? So you could either write this as 3.42 times 10 to the minus 2, right? Or you can just do 0.0342. All right, but yeah, make sure that gets in the meters. These are negative 25.2 times 10 to the minus 6 coulombs, so on and so forth. Now, they're asking for the magnitude of the force, not the direction. So I'm not even going to draw a vector diagram because it's not asking me for directions. They just want to know the magnitude of the force. I'm not going to worry about the signs either. Get into magnitude. And it's not potential. If it were potential, I'd have to worry about the positive and negative. But it's not. All right. So we calculate the first one. I assume that this isn't where you had trouble. Was it part B?
I think, yeah.
Yeah.
Contact is separated, got me tripped up.
Yep. Okay. So we bring two charged objects into contact with each other. Let's just simplify. Let's say one's positive 2 and the other is negative 4, right? One object like this, one object like that. When they come into contact each other, what is the net charge going to be? Negative 2. What'd you just do? Just add them together, right? So in this case, we have a negative 25 and a positive 40.7. And when they touch, what do we get? Whatever this number is. Anybody get it yet? $15.5? So 15.5 microcoulombs is what survives after they come into contact with it. Why did they go down?
Because the positive
25.2 positive charges got together with negative 25.2 negative charges and canceled each other out, neutralized, right? Leaving behind 15.5 microcoulombs of positive charges that don't have dance partners. Okay, so then, right, they're then separated. So this positive charge, where does it want to be? As far away from the other positive charges as possible, right? Okay, so it'll spread itself sort of evenly around the outside of the two conducting spheres, and then we pull them apart. How much ends up on each? Half. That's how you get an even split and get charges to be as far away from each other as possible. So you take that charge, divide it by 2, 7.25? 7.75. I knew there was an area there somewhere. Okay. And it's, so that's, you get 2 of those, now that's the charge on each sphere, and you repeat the calculation we did in part A. Kirsten, do you have a question?
Yeah. What would happen if two positives hit each other?
They would just add together. Yeah, if it was positive and positive, like +2, then the answer becomes +4. If it was +1 and +4, you would get +5, and then when the split, you get 2.5. Yeah. This problem was a little bit of a tricksy little hobbitus. Other questions? Concerns? Life events? Video game news?
Can we do 4 on chapter 20?
20. That's right, something is due tomorrow. You know, I made a conscious choice this morning to not check to see how many have actually started it.
Thank you.
It's probably good for your health.
Been doing this for 23 years. I know how you work. It's changed. It has changed over the years. The patterns that students do.
Also, better or worse?
I mean, how can you compare the late 90s and early aughties to the tools that we have today? Like, it's apples and oranges, right? And I am not one to sit there and mourn about the good old days or do any of that kind of stuff. I'm not wanting to look up your individual scores. So yeah, it's just different. I think the real question is how are we gonna leverage what we've got? I will go out on a limb and say that the way they teach math now sucks. What question was it? 4. So many of you had trouble with this, and I was surprised. I really was. I was like, and so I was like, is it the draw? Like, is it how they drew it? Is it something?
Yes.
Is it something that I said? Was it lack of teaching? Like,
The drawing.
The drawings.
the drawing sucks.
And the go-to
Didn't help at all. Tell me how you really feel about this.
Take it out, quite frankly.
Okay.
The Go tutorial only tells you how to do it if you do it right.
Yeah.
If you don't get it right, they're like, well, why should I explain it to you?
This is the correct way. It's like, this is obvious, guys.
If that's something you're just
By
like,
going to the tutorial center, I'll only help you when you get it right. Good luck. Okay, so, oops, we are operating with this, right? It's length, area, cross-sectional area, total length that current is flowing through. And we need to know the direction of current in these objects. And the battery is telling us how that's going to be, right? Current flows from the positive side of the battery to the negative side of the battery. So current comes out of this wire flowing this way, flows down, and to complete the circuit has to flow through to where the other wire connects so that the current can start flowing up and back into the battery. Okay? So, what total length did that current flow through as it went through the copper block or whatever it is? Material, whatever this material is, right? It went through 4L naught. The length, so for calculating the first, or A, it's going to be whatever the row is that they gave me, times 4 times the length of the, L naught that they gave us, 4L naught, and then divided by the cross-sectional area, the area that is perpendicular to the flow of the current, which is the area of this face right over here. If I take that face out and I just draw it flat, it's got 2L naught and L naught, and how do you find the area of a rectangle? Length times width. This is going to be 2L naught squared. Who's still confused? It's okay. A little bit?
Can you calculate it and then see if it accepts it?
Sure.
I feel like I was doing it right the whole time and then it wasn't.
1.5 times 10 to the minus 2. 4 times my length, 7 centimeters, so 4 times 0.07. And then all divided by 2 times 0.07 squared, right? Let me get rid of one of these 0.07s, just to make my calculator. I'm gonna get rid of this 2. So there's just less for me to type into my calculator. 1.5 minus 2. 2.07. I got 0.42. Call it 0.43.
Alright.
Sorry. Did you want me to do it wrong first? You want me to do it wrong first? Okay. All right, so now the next one, okay? I gotta follow the current around. Coming out of the battery, it's flowing this way, it flows down right here and goes down through this thing, connects up, comes out this way, right, comes around that way. Gotta follow the current. So now, right, what in this statement of relationship right here, okay, what length did that current flow through? It went through L naught. Top to bottom, the distance is L naught. L naught. Okay, and then now I need the area of this face, the area, the cross-sectional area that is perpendicular to, right, the flow of the current. And if I kind of redraw that, it's a rectangle that's 2 L naught on one side and 4 L naught on the other. Kind of like looking at a top-down view there. There's blank faces. You're at that.
Because he just flipped.
The number would come out the same time, I think it's just the other way. That's why I was like, remember the, it's harder than the test.
No, it's so discouraging.
All I
Okay. The box, right? Okay, right? In this part, right, the current is flowing down into the top of this thing and coming through. So how far did it go? L naught, okay? Now we need to find the area of this face. It's 2 L naught times 4 L naught, isn't it? Okay, so maybe part of what you're struggling with here is rotating this thing in your brain, right? Visualizing what's going on here, right? For the first problem, which way is the current flowing? It went into this face, right? Flowed through and came out of this face, right? So what was the length it went through? 4 L naught, right? And then the area that we need? L naught times 2 L naught. We seeing it better now? Cross-sectional area, direction of flow for part B, right? So what is this area? Well, that looks like 8 L naught squared, isn't it? All right.
2 hours, okay.
8 L naught squared. Throw some numbers in, good to go. Okay, what about the third one? Now which way are we going through our block? We're entering in this face, aren't we? Yeah. The front face, and then coming out the back. Does one see it?
No, I don't like this shape because like 4L naught should be the longer side to me. And
Well,
it
okay,
doesn't
they
look like-
drew the picture so that it looks like it's all like 2L naught and 4L naught look the same to me.
Yeah.
And I made that mistake, I think, when the first person asked me about this, is I just said both were 4L naught, and they kept doing it, they're like, "Yeah, but what about the 2L naught?" I was like, "Oh, yeah, that." Okay, so you're absolutely right, the 2L naught should be shorter, right? But it doesn't change the fact that this thing is flowing in that way coming out the back, right? No, it's flowing into the back and coming out the front. The positive side is pointing towards the back, okay? So it flows in this way. So that means the current's going through here. So what's the length that the current passes through? It's 2L naught, okay, this side. And then the area, L naught times 4L naught.
I think something that you just clarified for me was that the L in that formula is the length that the current travels through the material.
Yes.
Not its total travel
Correct.
length was something that
Correct.
confused me. Because the book only uses examples of like 20 gauge wire or something. So it's like the entire length of the wire is what you're considering. Whereas
And-
when here, the little black line looks like the wire to me.
It is a wire, okay? It says, says it's through a piece of material. You're right. They should have said ignore the wires connected to the battery. That would have been more clear. It was obvious to me.
Not a physics professor.
Yeah, because you're right. The book does use a lot. So when you're calculating the resistance, say in a wire in a wall, you do use the entire length of the wire because that's where the current is flowing through all of that copper,
Sure.
right? What they didn't tell you here is that when you see a black wire like this in a circuit diagram, it's always zero resistance. When we draw those resistor diagrams, it's only the resistor that has resistance. The wires in between them that don't have resistance. I didn't write down this blue one. It's L over A. The length is, what did I say? 2L naught, and the area L naught times 4L naught. That's 4L naught squared. How do you find current once you know resistance? If you know resistance and you want current, what do you go for? Ohm's law. Get used to rotating things in 3 dimensions in your head. It's coming. Next week. Yeah, I'll
Bring some cubes for kids.
You're right, right? There's. Focus on the test this week, but I'll just say this for next week. I can't see.
Awesome.
Why?
I'm being honest.
You should bring like Legos for us.
Legos aren't gonna help. I wish they would. But I've got some tricks, but the thing I can't save you from is 3 dimensions. Just about everything we've done together, we've kind of faked into 2 dimensions. We can't fake it next week.
Why can't we fake it until we make it?
You'll see. Magnets are amazing. and hard. But you got better things to focus on right now. Speaking of which, you're gonna take this on Thursday, right? When are you gonna find out about your score? Monday. Okay, because you so some of you were used to getting your exams back on like a Monday, right? Some of you had 2A where we had the Monday lab, right? Yeah, okay, but the rest of you were used to getting them back on Wednesdays, right? So, yeah, look forward to that. Will I tell you what your score is before that?
No.
You can hate me for that, it's fine. What's that? I do send out notices to people that get perfect scores saying you don't have to come. Because the autopsy doesn't do anything for them. Those annoying people, right? It was never me. Never me. Yeah, I was the other end of the curve setting algorithm. If I wasn't at the bottom of the curve, I was solidly in the middle. Other questions? I think I'm glad I'm changing the homework that we do on Tuesdays. Right, you
So
would.
when they go and try and Discord, the like 17 of us who've done it.
Yes.
Will help.
Right. Yeah, I did put a plug in my announcer for the Discord that, please don't be that person 10 minutes before the homework is due that's in Discord trying to get help.
Just post the questions, that's probably like.
Yeah, don't be afraid to ask, but try to be 24 hours ahead so it's not a crush, right? Can I go over? You want me to just make one up?
I answered so many.
This is dangerous. Let's reduce some circuits. You're feeling stressed?
I said you look stressed.
Oh yeah, no, because I'm being asked to make up a question on the fly.
But his left hand isn't in his pocket, so he's actually.
Not yet. I have to hold my head up. I'm tired. And it's partially my fault. I was trying to be a good boy. And I run on Tuesdays and Thursdays. I'm preparing for a 10K. And because I'm dumb. And I had a physical therapy appointment today, and I knew I wasn't gonna be able to run. So I ran yesterday. Yesterday's my long day. I'm here from 7:45 to 2:30. Well, I'm here from 6 in the morning, 6 or 6:30 until 2:30 in the afternoon, but I'm, solid labs. And I'm usually just wiped out after that. And so I went home and I thought, oh, okay, I got physical therapy tomorrow, I'm not gonna be able to run. I should run today. So I went out running yesterday. 5 minutes, I kid you not, 5 minutes after I got home, physical therapy called and said my appointment was canceled and rescheduled. No! I'm not gonna run again today. I'm gonna go home and sleep. Oh, I'm so tired. All right, what are we doing? Circuit reductions. I usually draw the battery over here. Can I just do 1, 2, 3, 4, 5? Sort of my cheaty way of keeping track of things, right? So we'll do 1, 2, 3, 4, 5, 6. Those are their resistances and also my labels for them. All right, so where do we start? I gave you a clue as to where you always start. As far away from the battery as you can, you work towards the battery, right? Okay, that's just safe. You can try and make guesses about things, but it can be thrown out. Like 3 and 4, are they in series? No. How do you know 3 and 4 aren't in series? There's a junction between them, right? So you kind of want to do that. 1 and 2 aren't, right? So, but there are 2 that are in series that are like obviously in series. Like it's this dead giveaway. Which 2? 5 and 6. How do you know they're in series? They're connected without a junction between them, right? So it might be useful to just look for series connections first. Alright? So let's combine 5 and 6 together. How do we combine resistors in series? Just add them up. Now we want to maintain the connections of things that aren't being added up. 3 and 4. But this 5 and 6 now become a combined resistor, don't they? Of 11. Equivalent will be 5 plus 6, which is 11 ohms. Okay, all right. And then, sort of what's like my next, more or less, I hesitate to use that word obvious because you're just new at seeing these diagrams, but there seems like there's a lot of parallel left now. But 2 of them, I can pretty much say, yeah, definitely in parallel. 3 and 11, right? Okay, 3 and 11 definitely in parallel. Now, could I have drawn the 11 up here? Yeah, is it still in parallel with 3? Yeah, and by not, maybe not obvious, but rock solid, I know these are in parallel. My current coming in splits into 2 parts, and both of those same parts end up meeting together at another point, right? I can see where the path splits, and I can see where that same 2 currents come back together again. The same thing can't be said for 11 and 4. Okay, so just that's kind of what you're looking, right? When you're looking for parallel, and you want to know if 2 things are definitely in parallel, does the current going into the junction split, and then those 2 splits come back without interacting with anything else before? So how do we add things that are in parallel? Yeah, we do the 1 over business, 1 over 3 plus 1 over 11. And we remember when we're all done to invert everything, right? Can be written like that. 3 and 11 and add them and invert them. 2.36. All right, so what does my circuit diagram now look like? Well, battery, 1 ohm, didn't touch that one. 2 ohm, didn't touch that one. The 4 ohm is still down here, but the 3 and 11 came together, didn't they? Into a 2.36. So I've got my 1, 2, 4, and 2.36. Going back to the battery. All right. What's the next thing we're going to join up? There's definitely 2 that are in series right here, isn't there? There's no junction between them. So let's just add them up. 6.36, did I do that right? All right, and then my diagram now looks like a 1, a 2, and then I combine these together, but that doesn't change the fact that there's still junctions here. 6.36, 2, and 1. Okay, next combination. Series or parallel? It's parallel because there's junctions between them, right? So we'll put this parallel together, 1 over 2 plus 1 over 6.36, inverted. .52. And now I am finally left with 1, and that one, the 1.52, series or parallel? Series. So the total is 2.52. Sure. Now, the question could just ask you for the equivalent resistance. It could ask you for what's the total current in the circuit. Or what is the current that the battery is outputting. So if we knew that this was a 9-volt battery, how would you now find the current? Ohm's law, right? Okay. So it would be 9 volts divided by 2.52, whatever that turns out to be, would be the current in the circuit. Okay. Could ask you for the power that the circuit is consuming. How would you find the power? Current times voltage, current squared times resistance, voltage squared divided by resistance. Any one of those will produce the same answer. And if I've been really mean, I could ask you for what's the current in resistor 3. Valerie gave me a really bad face. Okay, in which case you have to start working backwards. I did not do that to you. You only get 10 minutes to answer a question, right? This one's probably going to take a little bit longer than 10 minutes just in getting to that point, isn't it? So I decided not to waste another 40 minutes of your life working backwards through it. So don't worry about working backward, but do be able to do series and parallel combinations. Did I answer your question? Did I cause fear? It was also circuits. I had to sit down. Any questions? What do you have to remember? Hmm? Hmm? You don't remember? Recording's still going. Screen is black. Wow. I know. Trying to figure out what it's doing. This is class is over. Microsoft Edge took over the window manager. There is, but it says it's out of, it could be OBS.
Like and subscribe, maybe.
That's really cute.
Yeah, it's